Hello and welcome to this first session of Public Economics third year level. I want you to specifically pay attention today because I'm going to do some work that might be some revision of your second year level. And at the end of the 3 sessions, you'll see there's going to be 3 video clips. I will give you an activity, so please stay with me and stay in touch as I go along and explaining the diagrams. First of all, I want to focus today on top-level general equilibrium and how that point is actually reached and why it is seen as a Pareto optimal point. The top-level general equilibrium point is sometimes also seen as allocative efficiency. So please keep that in mind as I go along. Now, the first condition that I'm going to focus on today is specifically efficiency in production. That is the situation where you cannot produce more of one commodity without reducing the production of another commodity. Now, what do I actually mean with this? If we go to the board, you'll see that I'm going to try and draw the highest isoquant curve but with the lowest isocost. You'll remember this from your second year work. Now, just remember you must first of all give names to the axis, and in this case, I'm going to call it capital and labor. First of all, this is the isoquant curve, and to get a line tangent to this curve is called the isocost curve. Now, the isocost curve is normally the slope at this point is the change in this axis, the change in y, over the change in x. So this is the first isoquant curve that I'm going to draw this morning. You'll see at this specific point, the marginal rate of technical substitution is equal to the slope at this point. Now, specifically, if I go and transfer this now into a Edgeworth-Bowley box, you'll see that what happens is the first curve that I'm drawing is x1, x2, and x3. And I'm calling this kx, lx, and I'm drawing this now into a box, the so-called Edgeworth-Bowley box, because remember I want to get efficiency in production, so I want to get all these points here. Now from this side, you'll see that on this side it will be ky, and on that axis it will be ly. So from this side, I'll be drawing y1. Sorry, that must be tangent. y2. And if you can see this, y3. Okay, so at each one of these, they are tangent, and we draw the so-called contract curve. We're connecting those points, and we're drawing the so-called contract curve. You'll see that at each one of these points, we say they are Pareto optimal. Pareto optimal meaning you cannot produce more of one commodity to get more of another commodity. So in other words, let's say we're at this point, point Q. It means that you have more of X and less of Y. So that is not a Pareto optimal point. Okay, so just please keep in mind what is Pareto optimality. You cannot make someone better off, or you cannot produce more of one commodity without reducing the production of another commodity. Now, if I want to derive the production possibility curve out of this, I'm going to draw it like this. It is a concave curve and not a convex curve. Please remember that. It's a concave curve. at all of the points here on this curve. And you can draw a line tangent to that point. At that point, the marginal rate of product transformation will be equal to mcx over mcy, which will also be equal to the relative price ratio. So the slope of this line here, again, the change in y over the change in x equals px over py, and that is your relative price. So just keep this in mind. This was for year, and this is now the condition for year. In the next session, we're going to look at the next condition, condition 2, the efficiency in consumption. This was the efficiency in production, and remember, there are 3 conditions. Thank you.